This is the example in Chapter 4. We'll do a few of the joints to show you how the method of joints procedure actually unfolds. First thing you have to do in any of these problems is to solve for the support reactions correctly. In this case, the RAV reaction is 3,667 pounds and the RFV reaction is 7,333 pounds. The other thing you'll want to do at the beginning is notice the angle that each diagonal makes. The angle will want to be identified because you'll want to break the member force or the joint force from the member down into the X and the Y components. Starting at joint A, we'll draw a free body of joint A, noticing that it has two unknown joint forces coming into it. AC, which I show away from the joint, and AB coming into the joint. Now notice that AB is broken down into its components. From this point, we'll write equations of equilibrium in the X and the Y direction. The Y direction equilibrium equation can be solved directly for joint force AB, being 4,584 pounds approximately. We can then enter this into the X equilibrium equation and solve for AC, being 2,750 pounds. We'll take those answers and you'll want to place those up into the big picture. Notice that those joint forces are transferred or flip-flopped down to the other ends of the member. So for instance, the joint force at AB down at joint A acting into the joint, 4,584 pounds, is transferred up to joint B and also acts into joint B. Going to joint B, first thing you'll notice is that we've already got the AB joint force, and we can break that down into its X and its Y components. There's two joint forces we don't know, BD and BC, but again I will write equilibrium equations in the X direction and solve for BD, and then I'll write an equilibrium equation in the Y direction and solve for BC. Then, as before, I can place my joint forces that I've just solved for, BD and BC, onto a big picture and then transfer those joint forces from B down to the opposite ends of the member BD and BC, because I will use those later on. The last joint that I'll do in this video is joint C, and again we start by drawing a free body diagram of joint C. Again, notice that we do have the vertical member known at this point, 3,667. That was from our previous joint, joint B, and the horizontal AC down there we do know to be 2,750 pounds, and again that was actually found from flip-flopping at joint A. Two things we don't know is CD. Again, notice that I break CD down into its X and its Y components based on the angle of that diagonal being 53.1 degrees. Also notice that CE is an unknown. I will write my equations of equilibrium in the X direction as such, and the Y direction as such. In this Y direction I can solve for CD. I will then plug that answer in for CD into the X equation and solve for CE. Again, I will put these answers of joint forces onto the big picture and then make sure that I flip-flop these to the opposite ends of the members as shown. The rest of the problem continues on in this fashion, going from joint to joint. Finally, down at your last joint, that should be a check joint or serve as a check where all the forces come out to be equal to 0.